What's going on, guys? In this video we are going to see how to solve this second order non-homogeneous differential equation using variation of parameters. The first thing is we have to find out the complementary solution, and also we have to find out the particular solution, and if we add them together, that's going to be the general solution. So we can say y is equal to complementary solution, that's yc, plus particular solution, that's yp. If we add them together, that's going to give us the general solution. Okay, now to find out the complementary solution, what we do is we pick up this first term. Like we have to make sure this is in standard form. For example, if you have something in front of this, any coefficient in front of this, you have to divide everything by that to get rid of this coefficient. Then you have to find out the complementary solution. Okay, now what we do is we pick up this y double prime minus 2y prime plus y, and we equate that one to 0. And then we write the characteristic equation for this one. In characteristic equation, if we have y double prime, we replace that one with m square. And if you have y prime, we replace that one with m. And if you don't have any prime, we just put the coefficient in front of that. That's just 1, and that's equal to 0. If you factor this one, you will get m minus 1, m minus 1. So from this one, you can see m is equal to 1, and this is repeated real roots. Repeated roots. Okay, repeated roots. So whenever we have repeated roots, the solution for the differential equation will be in this pattern. We will have c1, a constant, multiplied by e power. Since this is 1, we have to multiply 1 times x. That's just 1. That's just x. And then if we have repeated real roots, we have to put x like this, x and e power x, because second one also 1, so 1 multiplied by x, that's e power x. Okay, now we have the complementary solution. Now the next thing is we have to find out the particular solution. What we do is, this is our y1 and this is our y2, this whole term. Okay, whatever the 1 multiplied by constant, it's the y2. Now y1 is e power x and y2 is x e power x. Now we have to use this one to find out the particular solution. The particular solution will be in this pattern. Yp is equal to u1 y1 plus u2 y2. Now to find out the y1 and y2 are already here. y1 is e power x, y2 is x e power x. That's not a problem. We have to find out what is this u1 and u2, because after we find out u1 and u2, we have to multiply that one with this and put it in this equation, and that's going to give us a particular solution. Now to find out the u1, first we have to find out u1 prime. u1 prime can be found using this formula, w1 over w, and u2 prime can be found using this formula, w2 over w. Now to find out this u1 prime and u2 prime, we have to use Wronskian, and after we find out the u1 prime and u2 prime, we have to just integrate this one, and that's going to give us u1 and u2. If we integrate the derivative integral cancels each other, and we will find out the u1. That's our purpose, because we want to find out u1 and u2 into u2 to put it in this equation and find the final solution. Okay, now first we are going to use the Wronskian to find out the w. W is the one we divide everything. We had to find out that one. To find out that one, what we do is we put this y1 and y2 on top. y1 is e power x and y2 is x e power x, and then we take the derivative of this one. Derivative of e power x is just e power x, and here this is a chain rule. So first we take the derivative of x and keep the other one as it is. A derivative of x is going to be just 1, so e power x remains, and then we keep the x as it is and take the derivative of e power x, that's going to be just e power x. So this is going to be the derivative. After we put it in the 2 by 2 matrix Wronskian, we have to find out the determinant. To find out the determinant, you know that we multiply this one and subtract the multiplication of this one. E power x times e power x, that's going to be e power 2x plus x e power 2x, that is this multiplication, minus this, minus e power x times x e power x, that's going to be x e power 2x. Here you can see we can cancel these two things, x e power 2x minus x e power 2x, and we finally end up with e power 2x. Now we found out w. The next thing is we have to find out w1. Whenever you see w1, you can straightly put 0 on the first one. So you can remember, like when you have 1, you put the 0 on first. If you have 2, the 0 will be here. Okay, here w1, that 0 is here, and below that 0 you have to put g of x. G of x is whatever the value that comes after equal sign in the function. Okay, this is our g of x in this case, e power x ln of x. Okay, now for example, if you don't have this one in standard form, for example, let's say you have 2 or something like that, you have to divide everything and bring it into standard form. Then you have to see what is the value after this equal sign, because if you have something in front of it, it's going to change, right? So you have to be careful on that. Now in this case, it's already in standard form, so we can directly put it right here. And then other one remains the same. The second one is going to be x e power x, and the derivative of that one, that is e power x plus x e power x. Now again we have to do the, we have to find the determinant. 0 times this, that's going to be just 0, and minus this, minus x e power x times e power x ln x, that's x e power 2x ln of x, ln x. Now this is the only thing that's going to remain, minus x e power 2x ln x. This is our w1. Now the next thing is we have to find out w2. W2, the only difference is, instead of for first one, we put 0 in the first one for w1. For w2, we have to put it for the second one. For the first term remains e power x, and then the derivative of e power x is just e power x. The second term we put 0, and then we put the g of x below that, that's e power x ln of x, ln x. Okay, again we do the determinant. E power x times e power x ln x, that's going to be e power 2x ln x, and then minus e power x times 0, that's going to be 0, so we can just neglect that. And then now we have w1, w2, w. The purpose of finding all these things to find out the u1 prime and u2 prime. Now let's go ahead and find out u1 prime first. u1 prime is w1 over w. w1 we found out that's minus x e power 2x ln x, minus x e power 2x ln x divided by w. W is e power 2x. E power 2x, when you do that, these two terms will cancel, so you will get minus x ln of x. This is u1 prime. If you integrate that one, that's going to give you u1. So I integrate both sides. When you integrate, integration and derivative cancel in each other, so you will get u1. In the other side, there's going to be minus x ln x integration. If you integrate with respect to x, this is going to give you minus x square divided by 2 ln x plus x square divided by 4. This is our u1. The next thing is we have to find out the u2. Okay, let's use a different color. Okay, I continue here. Oh, let's use this one. Okay, I continue here. u2 prime, I'm finding u2 prime now. u2 prime is w. Let's note this one down because this is one of the important information. Now let's find out u2 prime. u2 prime is w2 over w. w2 is e power 2x ln x. We found out here. E power 2x ln x. E power 2x ln x divided by w. That is e power 2x. So we end up with ln x. And if you integrate ln x with respect to x, u2 is going to be integration of ln x with respect to x. If you do that, you are going to get x ln x minus x. Okay, now we have this one. We have found out u2 and u1. Now we can find out the particular solution, because the particular solution is u1 times y1 times u2 times y2. y1 and y2 are already here, and u1 and u2 we just found out. We have to just plug it in this equation to find out the particular solution. Now let's go ahead and get rid of all these Wronskian things. Now after we find out all these things, it's not necessary. Let's get rid of this. Okay, now we have u1 here, u2 here. Let's use a different color. Let's use white. Okay, particular solution yp is going to be u1 times u1 is here, minus x square divided by 2 ln x plus x square divided by 4 multiplied by y1. y1 is e power x plus u2. u2 is here. u2 is here. x ln x minus x ln x minus x multiplied by y2. y2 is x e power x. Now when we multiply, let's see what we come up with. x square divided by 2, so let's multiply, minus x square divided by 2 e power x ln x plus x square divided by 4 e power x plus x times x square e power x ln x, then minus x times x minus x square e power x. Okay, now let's see whether we have like terms. If we have like terms, we can add them together. Here you can see this this ln x square divided by 2 ln x. These two terms are similar. This term and then this term is similar, so we can add them together. That's gonna give us, this is 1 x square, this is negative half x square, 1 minus negative half, 1 plus negative half, that's going to be plus half. So we will get x square divided by 2 e power x ln x, and then x square divided by 4 e power x minus x square divided by minus x square e power x. These two are like terms. So instead of x square e power x, we can write it as 4 by 4 x square e power x, because if you have the same denominator, it's easy to add. So 1 over 4 minus 4 over 4, that's minus 3 over 4. Minus 3 over 4 x square e power x. So this is our particular solution. Now we found out the particular solution. Now the final solution is, the general solution is addition of this complementary solution and the particular solution. We already have the complementary solution, that's here. And we have the particular solution here. We just have to combine these two together, and that's gonna give us the general solution of this differential equation. Okay, y is going to be yc, that is c1 e power x plus c2x e power x plus x square divided by 2 e power x ln x minus 3 by 4 x square e power x. And this is our general solution for this differential equation. And here, whenever I do the integration, you can see that I didn't put the constant because the constant is unnecessary. Finally, all the constants is going to cancel anyway, so we don't have to worry about this constant. We can prove it, but I'm not going to prove it in this one. You can watch the proof in my videos. If you search in my YouTube, you will find it. And then that's it. This is our general solution for this differential equation. And if you are trying to learn differential equations, there are a bunch of videos in my playlist. I hope you guys watch that too, and don't forget to subscribe. See you next time.